All right, so the last part of this unit we're going to talk about is inequalities. An inequality is two values that are not equal. Two values that are not equal. You solve them the same way you solve equations. It's just that the two sides aren't equal to each other. That's why we use inequality symbols. So these inequality symbols, there are four of them. This is less than. This is greater than. The third one is less than or equal to. And the fourth one is greater than or equal to. So if I have the words x is greater than -1, I would write that algebraically as x is greater than -1. With inequalities, we can graph the solution to show that with inequalities, there are infinitely many solutions for any given inequality, which means there's a lot of different possible solutions depending on what the inequality says. So when we graph them, if it is greater than or less than, we'll use an open circle on the solution or the constant that's on the right side. If it is greater than or equal to or less than or equal to, we'll use a closed circle because the or equal to means that this number is a possible solution. So for number 1, x is greater than -1. That means x, the solution for this inequality, is any number that's bigger than -1. So we're going to put an open circle on -1, and we're going to shade everything that's to the right. Now, if your variable is on the left-hand side, your variable should always be on the left-hand side. That's so important. If your variable's on the left-hand side, then your inequality will point in the direction that you need to shade for your graph. So for this one, x is greater than, it's pointing to the right, which means when we graph this, we're going to shade everything to the right. Our arrow is going to be pointing in the same direction as our inequality sign. So that's how you know which way to shade. And whether there's an or equal to line under the inequality is how you know whether it's an open circle or a closed circle. Now, possible solutions. There are several different possible solutions for this. Any number that's bigger than -1 is a possible solution. So that means -1/2 is a possible solution because -1/2 is bigger than or greater than -1. 0 is a possible solution because 0 is bigger than -1. 1. Any number that's bigger, that's to the right of this number on the number line, is going to be bigger than -1. It's a possible solution. All right, number 2, algebraically says m is less than -2. So I would write that as m is less than -2. That is a less than symbol, which means I'm going to have an open circle on the constant, -2. And it's less than, so I'm shading all the numbers that are smaller than negative 2. My inequality symbol is pointing to the left, so I'm going to shade everything to the left. And now I'll look for possible solutions. Possible solutions are anything that's less than negative 2. So that could be negative 2.5, negative 3, negative 4. Anything smaller than negative 2. For number 3, I'm given the graph. The number or the constant is 0, because that's where the graph starts. So I've got 0 on the right side, and I have my variable on the left side. It doesn't tell me what the variable is, so I can just pick one. I'm just going to use x. So now everything is shaded to the right, so it's greater than. And it's a filled-in circle, so it's or equal to. X is greater than or equal to. X is greater than or equal to 0. And when you have an or equal to, whether it's greater than or less than, if you have that underline of the inequality symbol to represent or equal to, that means that whatever that number is on the right side, that's a possible solution. So 0 is greater than or equal to 0. 1 is greater than or equal to 0. 2 is greater than or equal to 0. A possible solution is anything that you can plug into that inequality that makes it a true statement. All right, number 3 says G is greater than or equal to negative 1. So I'm going to write that as G is greater than or equal to negative 1. It's going to be a closed circle on negative 1. And I'm shading everything to the right. G is greater than or equal to negative 1. So my possible solutions are negative 1, 0, and 1. And the last one starts at the 1. So my constant is 1 for my solution. I don't have a variable, so I'm just going to pick x. It's an open circle, so I know it's got to be less than or it has to be greater than. There's no or equal to here because it's an open circle. It's shaded to the left, so it's going to be less than. X is less than 1. And possible solutions are anything that's smaller than 1. 0, negative 1, 1. Negative 0, negative 1, and negative 2. When solving inequalities, you have to have your variable on the left-hand side. And then you solve it just like you solve equations. The opposite of adding 5 is subtracting 5. What I do on one side, I have to do on the other. And this is f is less than or equal to 2. So I make my graph. When you have your number line, make sure your numbers are going in even increments. You can't number a number line 0, 1, 5, 7, 8, 9. You got to go in the same increment. So I'm going by ones. It's going to be a closed circle on 2, and I'm shading everything to the left. For number 2, this is a division problem, so I'm going to multiply by 3 on both sides. M is greater than or equal to negative 6. Negative 2 times 3 is negative 6. So now I graph, put my numbers on the number line. It is a closed circle on -6, and I'm shading everything to the right because it's everything that's greater than or equal to -6. And for the last one, the opposite of multiplying is dividing. D is less than -2. So that's going to be an open circle on -2. And I'm shading everything to the left because D is less than -2. All right, so when you are solving these inequalities, so far we've had the variable on the left. Sometimes you might see it where the variable is on the right. But with inequalities, we did this with equations, but the same thing applies to inequalities, but it's even more important now. Order matters. So when you have a solution, the first thing you should see should be your variable. Then you should have your inequality sign in the middle. Just like we had with our equations, we had the equal sign. You're going to have your inequality sign in the middle. And then on the right, you're going to have your constant. That means that it doesn't have a variable beside it. And there's only one number that's there. That number does not change. So this is our final answer. It should be variable, inequality sign, and then the constant. Whatever that final number is once you solve it. If you have to flip-flop the sides of the inequality, you must also flip-flop the inequality sign. So if I have 11 is greater than B, if I flip-flop my sides so that B is on the left side and my constant is on the right side, then I also have to flip-flop the inequality sign. So 11 is greater than B is the same thing as B is less than 11. So if the inequality sign is open to the constant when the variable's on the right, then when I flip it, the inequality sign has to be open to the constant when the variable's on the left.